Hi everyone. In today's video, I will be going over the law of sines and cosines review, just 1 through 7 in this video. I actually covered 8 through 10 separately in a different video. Okay, for this you will need your calculator, preferably a TI-84, and a reference sheet. Now this reference sheet may or may not look like the one from class, it depends on which version we gave to you, and if it looks different, you'll notice the big difference is that this is missing the law of cosines, or sorry, law of sines. But no biggie, we can easily add it. So this is something you will be required to remember for the test. We know it's sine of A over A equals sine of B over B equals sine of C over C. That's the rule. So I'll keep that handy as I go. And we will obviously be doing these on a separate sheet of paper, how much space they take up. Number 1. Got our triangle ABC. We are given A is 63 degrees, little a is 18, and little b is 15. And we're just asked to solve. And I want to alter the directions here. On the test, we just require tens places, so I'm going to reflect that in this video. All right, so we are asked to solve the triangle. That's the goal. And we are given angle A, side A, and side B. I do want to take a moment and label this triangle, classify it. We have an angle and then the following two sides. This is an ASS triangle. That's the special triangle that can create up to 2 triangles instead of just the one. So, this means after we find our first piece of information, which in this scenario it's always the first thing we can find is an angle, we have to check and see if that angle could actually create 2 separate triangles, not just the one. So let's just proceed as usual. So we have angle A and its side A. If we have both of those pieces, that means we can start by using the law of sines. From here, we are able to find angle B because we have side B. That's the only place we could go. So let's find angle B. We have sine of B over B equals sine of, we're given the A's, A over A. Filling in, we have sine of B over little b is 15 equals sine of big A is 63 over little a is 18. Cross multiply. And we get 18 sine of B equals 15 sine of 63. Divide the 18 off on both sides to get sine of B by itself. Sine of B equals 15 sine of 63 over 18. Last but not least, to get the sine by itself, or to get the B by itself, we have to remove sine. So we take the inverse of both sides. So we end up with inverse sine of that whole fraction. And then calculator to get our answer. And if we round to the nearest tenth, that is 47.9. Now from here, here's where we have to consider the case of the second triangle. So there are 2 ways to tell if you have 1 or 2 triangles. One of them is my preferred way, which is just to kind of sit back, look at the triangle, and just kind of logically think your way through this. So B is smaller than A. And when we get a second triangle, we're exploring two scenarios. The first scenario, which is what we're going to always start with, B is acute. The second scenario is B is obtuse. If B is smaller than A, we cannot explore that obtuse scenario because this relationship is strict. This isn't by happenstance that B is smaller than A. It is by design. If you remember the angle-side relationship, the largest angle is across from the longest side, and the shortest side is across from the smallest angle. So the sizes match up. So notice that side A is bigger than side B. That means that this is going to hold for the angles as well. Since side B is smaller than side A, angle B must be smaller than angle A. So if we go explore another triangle where B is obtuse, it's clearly going to be bigger than A, and that's not going to work. So just sitting here and kind of going through that thought process I just went through with you, that's enough reason for me to know there is only one triangle. Now on the test, you are going to have to provide reasoning as to why you do have a second triangle or why you do not have a second triangle. You will have to explain to some capacity. So I'm going to give you two explanations. The first one is what I just went through with you. The second one requires more work, but for those of you who are doubtful, it will give you the proof you need. So if you want to just kind of word it the way I just said it, angle B can't be bigger than angle A. So it must be acute. And then I'll add the side note. Can't be obtuse. So there's the first reason. The second reason I will go through with you. Let me grab a separate piece of paper for this. Let's say that we looked at this triangle and we're like, no, I'm convinced that there could be a second one. So let's say we go through that process of trying to find a second triangle. So we're going to draw a second triangle, ABC. Now, since this is supposed to be a similar yet different triangle, I'm going to add ones to all of these so they are technically different. So I'm going to fill in the given info. A was 63 degrees, little a was 18, and little b was 15. So this information does not change. And then from here, we're trying to argue we can get a second triangle with the same information. So you start by getting your angle B. If we try to solve for it, we're going to end up with the same number. So instead, we get this by doing 180 minus the original B I got, the other angle. So it's 180 minus 47.9. Which is 132.1 degrees. Goodness. Now, here's where it falls apart. If we were to continue the process of solving this triangle, which if we have a second triangle, that's what you're supposed to do, we will try to find C next because we already have two of the three angles. So finding C is easy. So to get C, it's 180 minus 63 minus 132.1. And we get negative 15.1 degrees. Now, as you can imagine, you can't have a negative number for C. It's not possible. So, since that fails, we know we can't have a second triangle out of this. It doesn't work. The math falls apart. So, this is our second possible explanation. Option 2. The angle measures in the second triangle would exceed, or just more simply, be more than or be greater than 180 degrees. So if you want to go through the math of it to figure out that it fails, you can do that. This is definitely a safe way to go about it, because if you struggle with trying to just decide by looking at it, you may incorrectly assume that there isn't a second triangle, and there actually is, and then you passed up on finding it. Had you thought maybe it wasn't, but still tried to find it, you would have found it. So this is a safe approach, but the first approach saves you time. So there are pros and cons there to either way you do it. So I'm going to put a big or here. So either way on the test, as long as you can explain, and you can explain it in a mathematical, clear way, why you do or do not have two triangles, you will be all set. All right, so we know we only have one triangle, so let's just finish solving that one triangle and we'll be done with this problem. Okay, that was angle B. Next, we can very easily find angle C, because the three angles add to 180. 180 minus 63 minus 47.9. $69.1 degrees. And lastly, we have to find side C. This will be law of sines. Sine of C over C equals, reminder, when you use law of sines, it is always best to use the given pair that you have. Those are the most accurate numbers. The B's, we had around to get those, so not ideal. So sine of A over A is going to be our other half of the proportion. Filling in, we have sine of big C is 69.1 over little c is unknown equals sine of A is 63 over little a is 18. Cross multiply. And we get 18 sine of 69.1 over, or sorry, not over yet, ignore that, equals c sine of 63. I like to get ahead of myself. Then we divide by sine of 63 on both sides to get the c by itself. This is where the over comes into play. These cancel. And then I'm just going to type this into my calculator. So this will give us our c value. (18 sine of 69.1 over sine of 63. Rounding to the nearest tenth, we have 18.9. And that is all for number 1. A long problem for sure, but that's about as bad as it would get unless we would have to find the second triangle. That would be quite lengthy, but thankfully that did not happen this time around. All right. Number 2. Triangle ABC. And then my numbers are, fill these in, little a is 5, little b is 3, little c is 7. Classify, this is a side triangle, no special case, special anything we have to be concerned about. So that's lucky for us. You just jump right in and start solving. So, side, side, side. Again, our goal here is to just solve. And we are given all the sides, A, B, C. Now, kind of go-to principle we have here. When we're solving triangles, we have two things at our disposal. We have the law of sines and the law of cosines. If you can't use law of sines, then you have to use law of cosines. We don't have an angle at all, and we can't get one either, so we have to use law of cosines. And we are going to use it in a backwards way. We'll plug in all three sides. It doesn't matter which formula we use yet. And we can find any angle. Now, you can just dive in, go alphabetical order with this. But there is a strategy here. So reminder, the law of cosines is more complicated work-wise than the law of sines. So ideally, if we can use law of sines sooner rather than later, that's going to be the fastest way to get through the problem. Now, you have to remember with the law of sines, you have to be careful. The law of sines can't be used to find the biggest angle. Law of cosines, you can find any angle you want. And that's why it's so handy. Law of sines, you can find any angle, just not the biggest one. It does not always work. So we can do ourselves a favor, find the biggest angle right out of the gate, because we have to use law of cosines to start the problem anyway. Let's go ahead and find the angle that we can't find with law of sines, and then we can switch to law of sines for the rest of the problem. That'll make things easier on us. So let's identify the biggest angle. Biggest angle. Find the longest side, that is 7. So the biggest angle is angle C. So let's find angle C. I'm going to write some directions on here. It might help those of you at home. Find angle C first. Then we can use law of sines. Law of sines. So that's what I'm doing. Okay, so let's find angle C. And space-wise, we're going to start down here. So we have to use law of cosines again because we don't have enough info to use law of sines. Since we want angle C, we're going to use this formula here. I'm going to write that out first. C squared equals A squared plus B squared minus 2AB cosine of C. I recommend looking at that as you write it so that you don't make any mistakes. Filling in our numbers, we have 7 squared equals 5 squared plus 3 squared minus 2 times 5 times 3 cosine of C. From here, we will carefully solve this. One thing I'll get to in a sec. I'm going to go ahead and start breaking these down. 7 squared is 49. 5 squared and 3 squared, that's 25 plus 9, that is 34. Now, you can multiply these out, but you cannot combine this with these terms, with the 34, because this has a cosine attached to it. This does not. They are not like terms. Minus 30 cosine of C. And then next, we are going to subtract the 34 to both sides. I will show this one good time. Show my work, if you will. 49 minus 34, this is 15, equals negative 30 cosine of C. I'm going to divide by negative 30 on both sides. This is negative 15 over 30 equals cosine of C, and then inverse cosine on both sides. Inverse cosine of negative 15 over 30 equals C, and this is actually a nice number if you put it in the calculator. (120°). So C is exactly 120. Now that we have found C, we can use the law of sines to find another angle A or B. It really doesn't matter where you go from here. I'm going to go with A. I'm going to kind of break off my work here. It's going to get a little smush in a moment. Next, I'm going to find angle A. Since we have the C pairing, side and angle, and we have the biggest angle in the triangle, we can use law of sines. Sine of A over A, since I want to find A, and then we're using C's. Sine of C over C. We have sine of big A is unknown, little a is 5, equals sine of 120 over little c is 7. Cross multiply. We get 7 sine of A equals 5 sine of 120. Divide off the 7 on both sides. Sine of A equals 5 sine of 120 over 7. Inverse sine on both sides. A equals inverse sine of that whole fraction. 5 sine of 120 over 7. And then our calculator will give us the answer. Inverse sine, 5 sine of 120 over 7. 38.2 degrees. All right, we are almost there. We know that to find B, we just have to subtract both of these from 180. I will just do that in my calculator. (21.8 degrees). That is our angle B. And we have fully solved our triangle. Moving on, number 3. A, B, C. We have, let me do the sides real quick, A, B, C. Number 3, angle B is 47 degrees. Angle C is 62 degrees, and side A is 10. Classify, we have 2 angles with a side in between. This is angle, side, angle. And for a solving problem, this is actually really nice to start off with, because we can right off the bat find something that's missing in the triangle. When you have 2 of the 3 angles, we can easily find the third. So then all we have to do is find the 2 sides. So I can find A using my calculator. I have 180 minus 47 minus 62. So right off the bat, I know A is 71 degrees. Now, remember the goal is to solve. Always keep the goal in mind, because we've got a few different things going on this test, on this study guide. We are given, I will go ahead and add all the angle A in with that list, since I did find it pretty easily. A, B, C, and side A. Without that angle A, we didn't have enough for law of sines, and also we didn't have enough for law of cosines. Law of cosines requires 2 sides and an angle. This is 2 angles and a side. That was not going to work. So, finding angle A, now we've opened up a pathway to solve the problem. So putting those two together, we can use law of sines to solve. And we don't have to worry about trying to find the wrong angle or anything. We know all three angles, so we're good. So we need to find sides B and C. I'll just go in alphabetical order. Starting with side B. Sine of B over B. And we have the A's. Sine of big B is 47. Little b is unknown. Sine of big A is 71. Little a is 10. And the nice thing is sides are really easy to find. A little easier to solve for on these problems. We get 10 sine of 47 equals b sine of 71. Divide off the sine of 71. These cancel. And then I'm just going to go ahead and type that into my calculator to get my b value. We have 10 sine of 47 over sine of 71. Rounding, we get 7.7, rounding to the nearest tenth. So side B is 7.7. Lastly, we just need to find side C, and we're going to do this in pretty much the exact same manner, except we're going to have sine C over C. Still using law of cosines. Still using the A's as our given pair. Okay, filling in. We have sine of big C is 62 degrees. Little c is unknown. Copy down the A's from above. Sine of 71 over 10. Cross multiply. Sine of 62 equals c sine of 71. Divide off the sine of 71. These cancel. And again, I'm just going to go straight into my calculator for the answer. The good news is I only have to change one thing in the previous calculation. Change the top angle to 62, and we're good to go. 9.3 when I round to the nearest tenth. I have found all missing information, so I'm done with the problem. We have one more of these, number 4. Triangle ABC, and then ABC. Angle A is 53 degrees. Side C is 17, and side B is 20. So here we have two sides with an angle in the middle. That is a side angle side triangle. I can't find any angles right off the bat, so let's just look at our given information. And don't forget the goal is to solve. Let's look at our given information to see where to go from here. We have angle A, side B, side C. So we have one of each letter, and two of those three are sides. That means we have a perfect setup for law of cosines. So we're given angle A, and again, we can't find any other angles, so we have to use the top formula. We have angle A and sides B and C, so we will very easily find side A. So A is going to come first. Formula, A squared equals B squared plus C squared minus 2BC cosine of A. Make sure you are copying that down straight from the reference sheet. That way you don't make any silly mistakes. All right, filling in. A is unknown, so this is still a squared. B we know is 20 squared plus 17 squared minus 2 times 20 times 17. Cosine of A is 53 degrees. Before you type all of that into your calculator, reminder, our goal is to find A, not A squared. That is accomplished by square rooting both sides, and in particular the right side. So make sure you put all of that under a root when you enter it into the calculator. So square root, 20 squared plus 17 squared minus 2 times 20 times 17, cosine of 53. 16.7 when I round to the nearest tenth. So that is my side A. I just need to find 2 more angles and then I am done. All right, from here, I finally have the information to use law of sines. Now, here's the problem. I don't have the biggest angle in the triangle. The good news is I know what the biggest angle in the triangle is. So remember, you can't use law of sines to find the biggest angle. It will not get you the correct answer. So don't use this to find the biggest angle. Let's identify what the biggest angle is. Longest side is 20, which is side B. So angle B is the biggest. So you can do one of 2 things from here. You can either continue with law of cosines again if you want and solve for B or C. Choice is yours. If you want to take a slightly shorter route and use the law of sines instead, you have to use it to find angle C. You cannot use it on angle B. It will not give you the correct answer. So if you want to switch to law of sines, make sure you find C, because once we have A and C, then we'll easily find B. So I'm going to switch to law of sines here because I find that easier. So we have sine of C over C because we're finding C, and then we're given the A's. Filling in, we have sine of C over little c is 17. Sine of big A is 53 over little a is 16.7. Cross multiply. We get 16.7 sine of C equals 17 sine of 53. Divide off the 16.7 on both sides. Canceled. Sine of C equals 17 sine of 53 over 16.7. Lastly, we take the inverse sine on both sides. That whole fraction. And then calculator to get our answer. Nope. Did not mean to turn it off. What happened? Okay. Weird. Inverse sine. 17 sine of 53 over 16.7. 54.4 degrees. So that's angle C for us. And then luckily for us, angle B will take no time at all to find. We just subtract the two angles from 180. $72.6 degrees. All pieces of the triangle have been found, so we are completely done with the problem. And we are done with fully solving triangles for the video. Now let's switch to the shorter problems, the area problems. We have 3 of those, and we are going to be done. Number 5, and we're finding area. Before we forget, we are not solving. It can very much look like a solving problem, but that's not what our goal is. Now, before I dive too much into this, let's talk about area for just a moment. When you're finding area, these are your 2 options. You have Heron's formula and SAS triangle formula. Heron's formula is really only beneficial if you're given a side, side, side triangle. Anything else, I'd recommend SAS. You have to have all 3 sides because it is in both formulas. You can't find the area if you don't know all 3 sides. Meanwhile, SAS triangle just requires you to have 2 sides with the angle in between them to be known. Now, there's a lot of flexibility with this, and even if you're given a triangle that doesn't fit into a category, this is where you can go into solving parts of the triangle until you get enough information to use one of these. And 9 times out of 10, you're going to get the information to use SAS before you get the information to use SSS. So for that reason, I always recommend SAS unless you are given this right out of the gate. Plus, SAS is less work. Okay, number 5. Let's set up our triangle and see what we have. ABC. A, B, C. Side A is 5. Side B is 3. Side C is 7. So, this is clearly side, side, side. So, we will go ahead and use Heron's formula. Since we were given side, 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 why not? That would be the easiest thing to do. So Heron's formula is actually 2 formulas. You find the S value so you can plug it into the area formula. So S, to find that, all you got to do is add all 3 sides together and divide it by 2. So we have 5 plus 3 plus 7 over 2, which is 15 over 2. Now you can use 15 over 2, or you can write it as a decimal. It's very nice, 7.5. Now plugging it into the area formula. The area is the S times S minus A times S minus B times S minus C. I'm going to fill that in. We have 7.5, and then 7.5 minus A is 5. 7.5 minus our B is 3, and then 7.5 minus our C is 7. I will definitely be putting that into a calculator and rounding to the nearest tenth. Okay, 7.5, 7.5 minus 5, 7.5 minus 3, 7.5 minus 7. And we get 6.5 when rounded to the nearest tenth. And then don't forget the units squared. Units squared. And we're done with number 5. 2 more. Number 6. ABC. ABC. Angle A is 53 degrees. C is 17. B is 20. Identify it, classify it. We have SAS. 2 sides with the angle in between them. So this is a perfect candidate for the SAS triangle formula. Let's figure out which version of the formula we will use. Again, our goal here is to find area. We are given angle A, side B, side C. Angle A is only in one formula. It's the top one with sides B and C. So this formula is what we will use. Area equals 1/2 BC sine of A. 1/2, B is 20, C is 17 times sine of 53. Calculator to get our answer. $135.8 is our area. And then you can just abbreviate it to U squared if you prefer. All right, last problem for this video, number 7. And I'll go and tell you number 7 requires a bit more work than the other two. So just a heads up there. A, B, C, A, B, C. Okay. Angle A is 63 degrees. Side A is 18. Side B is 15. All right, let's identify this. We have angle, side, side. Now, we don't need to find a second triangle here, obviously, but we do just need to be aware we have to be careful here because we don't have enough information in the triangle to put this angles in order by size yet. So we don't want to do anything that we're not supposed to, is what I'm saying. So this is just your warning, be careful. Okay, so again, the goal was to find the area. And if you couldn't tell, ASS does not fit into either of these. So we need to find more information until we have enough to use either formula. Once again, you're going to get that information for SAS before you get to SSS. So I always go to SAS on these types of problems. So let's just figure out what we do have. We were given angle A, and then sides A and B. Now, we have a lot of flexibility in here, so we can sit here and try to figure out what the best formula would be to try to use, but the given information guides us in a specific direction. So let's just solve for something, and then we'll reevaluate from there. So I'm given the pair of A's. That means that I can use the law of sines. And that is why this problem is a bit concerning. We have to be careful because the law of sines doesn't work all the time. If you're trying to find the biggest angle with it, that's not the way to do it. Okay, so I'm also given B. So when I use law of sines, I'll be finding angle B, the missing B. So let's start there. We have sine of B over B, because that's what I'm looking for. And then I'm given the A's, sine of A over A. Filling in, I have sine of big B is unknown, little b is 15, equals sine of big A is 63, little a is 18. Cross multiply. We have 18 sine of B equals 15 sine of 63. And our goal is to solve for sine of B here, so we will divide off that 18 on both sides. These cancel. Sine of B equals 15 sine of 63 all over 18. Last step, we take the inverse sine of both sides. Inverse sine of that whole fraction. 15 sine of 63 over 18. inverse sine of 15 sine of 63 over 18. 47.9 degrees for angle B. Now, this is where the ASS, like ambiguity, the special case comes in, where if B were a larger angle and larger than A, then maybe B was supposed to be obtuse, and we would have to explore that option. B has to be smaller than A, and we could have been able to say that from the beginning because side B is smaller than side A, so we know that angle B is smaller than angle A, so we're good there, no worries. Okay, so let's see if we have SAS now, because remember, we're just going, because our goal is to get the area, and to get area, we need SAS. We're going as far as we need to until we have SAS. So right now, I need two sides and the angle in between them. My two sides are A and B. The angle in between these two is angle C. I don't have it yet, but I can very easily get it because I already know the other two angles. So let's do that. Angle C is 180 minus 63 minus 47.9. $69.1 degrees. And now I finally have SAS. If you don't see it, I've got my S, my A, and my S. I can finally use that formula. So, SAS triangle formula, and we have, for the area, we're going to use parts A, B, and angle C. That's what we're able to use from the triangle because they're in the correct order. Now, the only formula that uses angle C is the bottom one, so that's what we will use. So we have 1/2 AB sine of C. 1/2 A is 18. B is 15. Sine of C is 69.1 degrees. Plug that in and we will get our final answer. 1/2, 18, 15, sine of 69.1. And we end up with 126.1 units squared for our area. And that is the first 7 problems on the study guide. I hope that this video helped. I hope that I was able to go more in depth and explain things a little better and to make you understand the material a bit more. If you have any additional questions, feel free to reach out to me via email or come see me in person. If you're curious about problems 8 through 10, go check out that video as well. Otherwise, I hope you have an awesome day. Bye!